Okay, let me just check if you guys are already in front of your computers. So again, just give me a thumbs up. Okay, 5 out of 9 or out of 10. So maybe the others went to bathroom or doing something. Anyway, all right. So the first thing that I uh, just would like to mention is with your, of course, midterm exam. I'm quite disappointed. Okay, so I will not show to you guys your scores anymore because some of you really get a very, very low score. So when I mean low score, you can think of the worst score that you can think of. So uh, none of you were able to pass the midterm exam. Okay, so literally all of you failed to have at least 60 out of 100 on your midterm exam. Okay, so what happened, guys? So where is the hardest topic? Okay, that you guys have a hard time? Anyone would like to share? Kung saan kayo nahirapan, parang nalilito kayo, maybe. Hello, hello. So what can you say, guys? Let's talk about your midterm exam. So what happened? Okay. Your highest was 55 out of 100, and all we know, 55 or 59 is not the passing score because the passing score is 60. Okay, so the highest was 55 and still not uh, enough to pass the midterm exam. So what happened? So anong naging problema natin sa midterm exam natin? Kulang ba sa oras? Is the uh, problem super difficult? Wala talaga, wala magsasalita. Okay, let me ask you guys one by one. Mr. Murillion, Mr. Aaron. Mr.
Uh,
Aaron.
yung Kirchhoff and Maxwell. So, mahirap sa akin, sir.
Mm-hmm. How about the
Yeah.
superposition and then the nodal voltage?
Yes. May
Yun din.
nalilito rin po ako doon.
So basically parang lahat. Okay. What
Yes,
about you,
sir.
Mr. Aaron Paran?
Sir, personally, I think the mesh current, sir.
Yun yung pinaka mahirap
Yes,
para
sir.
sa'yo. Okay.
Specifically, the part na you're going to equate the three equations.
Yeah, yeah. So mostly ganun. So always expect that, if I am giving you guys example of, let's say, two loops only, we'll expect that in exam or in your quizzes, you're going to have three loops, okay, or even four. Okay, that's already the worst case scenario. So I think five, medyo masyado ng complicated yan. So maybe four or three. So I think okay naman sa iba. Okay, when I've checked the this one, this statistic, at least 60%, 50 to 60%, most of you got the Kirchhoff's law and then the mesh analysis. Okay. Well, anyway, let's talk about the superposition and nodal voltage analysis later on. How about you, Mr. Francis Alburo? So, saan ka nahirapan?
Na-overwhelm ako sa mga figures, sir, and sa ano din, Maxwell's, Kirchhoff's,
Mhm.
superposition.
I see. Okay. How about you, Miss Sophia? Miss Sophia Nicole? Are you around? Okay, so, all right. So maybe her mic is not working. Okay, so Maxwell din daw. Okay. How about you, Mr. Nathaniel?
Sir, sa superposition po.
Superposition. So, yeah. No doubt about it. How about you, Mr. Michael Maba?
Sir, I guess dun po sa ano yun, sa superposition din po. I thought kasi, pero ano, I don't know if I understood the Kirchhoff's law and then the mesh current analysis, because I think I did. I think I got how to solve the how to solve problems involving Kirchhoff's and mesh current analysis, but I guess I didn't. I don't know. I don't know kasi my score.
Hmm. So you guys can yeah, because I haven't checked your midterm exam yet. But to mention, okay, so ito na lang, just to make it an inspiration, okay, just so that you guys know who is the highest. The highest was actually Mr. Maaba. So the score of Mr. Maaba was 55. Okay, so though bagsak pa rin yun. Okay, so yeah, that's your score. And then the others, yun. So hindi ko alam kung anong nangyari. Sobrang baba talaga. Well, anyway, okay, so that's it. How about you, Miss Leah?
Sir, superposition din po, tsaka Kirchhoff law. Nalito na po ako, sir, sa mga sa mga figure, ganun po. Pati rin po yung mga nahanap.
Mhm.
Lang, sir.
Okay. How about you, Mr. Isagani? Mr. Donato, are you there? Sir, nodal analysis, tsaka di ko po nakapag-practice na maayos. Okay, yeah. Alright. How about you, Mr. Sajin Vicente? Sir Samash at Maxwell. Okay. How about you, Miss Ginoran? Miss Grace? Okay. Kaya niya yata magsalita. Maxwell and superposition po. Okay. Well, when I check the statistics of your exam number by number, so most of you, of course, got the number one, since that's the basics, the Ohm's law. And then most of you, at least 50 to 60%, most of you got the Maxwell and then the Kirchhoff's law. However, on your superposition theorem and then nodal voltage analysis, I think there were only one, okay, and then some, ano man tawag dito? Some have a super close answer, but it's not just within the range. So I think meron lang pagkakamali ng konti nung chine-check ko, kasi parang tama naman yung solution pero mali pa rin yung sagot. So I don't know what happened. So yeah, parang isa lang or dalawa yung nakakuha ng kasi 'di ba parang sa superposition dalawang question. So meron doon nakuha niya isa, yung isa wala, parang gano'n. Gano'n din sa nodal voltage. Yung isa nakuha niya, yung isa din wala. So parang literally there's only one or two students who got the correct answers in some numbers, okay, in some questions of superposition and nodal voltage analysis. Okay, and that's a total of 40 points, I guess. So that is why here's the remedy. Okay, so as you guys can see right here on my screen, I did put here an additional points for midterm exam, since this is where you guys are really having a hard time. So alam ko kung saan kayo nahirapan, kasi nakita ko na yung uh, score nyo. So ito yung parang nakita kong wala talagang nakakuha. Okay, so kinaklarify ko lang. Well, anyway, so yeah, I would like you guys to answer this one. So I am giving you guys exactly 1 week. So this is 40 points, additional 40 points to your midterm exam. Okay, so whatever you will get in here will be added as your score in midterm exam. Okay, so are we clear with that one?
Yes, sir.
Okay, so yung mga mababa yung score, so malaki yung chance. So, Mr. Maaba, kapag na-perfect mo to, so you'll get a total of 95 out of 100 already. So, yung mga bitin, let's say 20, 15, so this is now your chance to have a higher score, okay? So, make sure to practice superposition and nodal method analysis. Okay, so mag-solve lang kayo ng maraming mga questions, maraming mga tutorials sa YouTube, and then eventually maybe maintindihan nyo rin, okay, ng talagang buong buo, and then you'll become ready, okay, upon answering this additional points. Okay, so yeah, that's it for your midterm exam. So I am really sorry, but I will not discuss the solution. Okay, if you want to know the solution and specific number, you can message me. Okay, and then maybe I can give you some hints, but I cannot give to you the correct answer. Okay, that's because and magkakaroon kasi tayo ng parang leakage. Okay, especially to those students who haven't finished their midterm exam yet. So magiging unfair na kapag nalaman nila yung sagot, and yun. So ilalagay na lang nila yung sagot. Okay, so yeah, maybe I can give you some hints. I can teach you how to do it, but not the exact answer. Okay. All right. So since we're done with your midterms, so we're going to discuss now the modules in finals, of course. So week number 4, module 7 and 8, which is the Thevenin's theorem and then the Norton's theorem. So I already published the entire module. Okay, so you can find here the 2 PDFs. So just download those and then do an advanced reading. Okay? Bago natin i-discuss mamaya. Kasi tatapusin din naman talaga natin to ngayon. Okay? Well, anyway, just download this one now so that you can have your own copy. And of course, as usual, you can find here the tutorials that I did included. Okay, so we have here 3 links for the Thevenins and then 2 links for the Norton's theorem. So all of them came from YouTube. Okay. And what else? So I also included some external websites wherein you can practice some of your knowledge when it comes to Thevenin's theorem and then Norton's theorem. Okay, and then of course, as usual, we're going to have a quiz with this Thevenin's theorem and then Norton's theorem. Okay, so i-unpublish ko lang to kasi dito nyo isasubmit yung solution nyo. Okay, and dito rin. Okay, so just submit your solution on the Thevenin's and the Norton's theorem. And then, of course, for the case study number 4, same, July 29. So exactly 10 days actually, okay, not 1 week. So you guys have 1 week and 3 days to finish those 3 activities. Okay. So are we clear with this one so far?
Yes, sir.
Okay, so do you guys have a question before we proceed with our official discussion for the Thevenins? Or any clarification? Okay, so I guess none. All right, so let us start now with the Thevenin's theorem. Okay, so let me just open a notepad. Okay, so in Thevenin's theorem, okay, so we have this terminologies like RTH, VTH, and then of course the R. Of course, you guys already know this one. This is the R load, okay, or the load resistance, and then RTH is the Thevenin's resistance. Let's make this one bigger. And then Thevenin's voltage. Okay. So those are the things that you guys need to find when it comes to Thevenin's theorem. Okay. So this one is quite similar with the Norton's theorem. Okay. So the counterpart of RTH in Norton's, we call that one I N. Okay, or I Norton exact, but just uh, make it short as IN. Okay, not in, but it's IN or I Norton. Okay, this one is the Norton's current. My bad. Not the counterpart of RTH, but it's the counterpart of the VTH. Okay, so for the Norton's resistance, Okay, so this one is ITH. Okay, R N, not ITH. Okay, so Norton's resistance and then Norton's current. Okay, so as early as of now, I would like you guys to know that the way that we solve for the RTH is the same on how we solve for the RN. Okay, so it's like hitting two birds with one stone. So with that, we could say that they are really super similar. They just differs when it comes to this one has a current, but this one has a voltage source. Okay, so of course this one also has an RL or the R. Okay, all right. So enough with the terminology. So let's start now with the Thevenin's theorem. So the Thevenin's theorem is another theorem wherein, oops, bakit sumasabra? Is another theorem, of course, that make possibilities that wherein we can simplify any linear circuit, no matter how complex it is. Okay, as long as it's a linear circuit, but we can convert that one into a Thevenin's circuit, and then find the RTH and then the VTH and then the individual currents and then the individual voltage drops on that circuit. Okay, so again, as long as it's linear and then there's no exponents or roots on that circuit. Okay, so if we have resistors, inductors, and capacitors, that is possible. But if we have gas discharge or semiconductor components, that is not possible because that's already a non-linear circuit. Okay, so just do take note on the limitation again of the Thevenin's theorem. This one is only possible if we have a linear circuit. So without a further delay, let's use again the same example. So as you guys can see, we're still using the same example from Maxwell to superposition to nodal voltage and then to uh, Thevenin's theorem. So that's because we would like to compare how they differ when it comes to solving the voltage drops on R1, voltage drop on R2, voltage drop on R3, the current on this right side, the current on this left side, etc., etc. Okay. So with that being said, let's use this as our example in this Thevenin theorem. So the first thing that you guys need to do, okay, is where or identify where is the load. So that depends on the question. So this could be a load, this could be also a load, okay, or this could be a load. So in this particular example, the chosen load is this R2 right here, okay. So just do take note that a load can be found anywhere on the circuit. Okay, it's just that the load right here right now is the one that is in the middle, which is the R2. Okay, so once you find the load or the R load, so just remove that one. Okay, that's the first step when it comes to Thevenin equivalent circuit. So after removing that one, okay, so where is that remove? Okay, so you will have this circuit. But before that, let's go right here. Okay, so our goal, okay, is to convert this original circuit into this Thevenin equivalent circuit. So going back with our terminologies, so the one that we are solving when it comes to Thevenin's theorem is the RTH, VTH, and then the RL. So RL is already given, so no need to solve for that one. But for the RTH and then VTH or ETH, so those are the things that we need to calculate. Okay, so once you have the values of RTH and then the ETH, then you can now have this one as your final circuit for the Thevenin equivalent circuit. And then from here, you can now calculate the current that is flowing on R2, current that is flowing on R Thevenin, the total current, the voltage drop on this one, the voltage drop on this R load, and so on and so forth. Okay, so yeah, that's basically it for the Thevenin's theorem. Okay, but of course, how do we solve for the R Thevenin and then E Thevenin? So we have this step-by-step solution right here, but just to make it short, okay, enough with the explanations. I'll leave the reading part to you guys. So first, the chosen load resistor is removed from the original circuit, replaced with a break or open circuit. Okay, or break it or just leave it open. So that is the first step. Okay, after removing that one, then you can now solve for the voltage drop on R1, voltage drop on R3, the total voltage drop, the current on R1, the current on R3, the total current, okay, and then of course they're given values of resistance, okay, which is 4 ohms, 1 ohm, and then the total resistance, which is 5 ohms. Okay, now how did we arrive with those values? So you can use any law that you can think, okay, you can think of. So you can use Ohm's law in here. You can even use Kirchhoff's voltage law. Okay, you can even use superposition theorem if you want, since that's also possible, since we have two voltage source in here. You can even use nodal voltage analysis if you want. Okay, so any theorem that you can apply to find the RTH and VTH, so you can use that one. Okay, now let's have now the solution for the RTH. Okay, let me just copy this one. Okay, so the original circuit, oops. So the original circuit was this one. Okay, and then of course the first step is to remove the R load. Then after that, we will arrive with this kind of circuit. Okay, so we now have an open RL right here. Okay, so now where can we solve? Okay, where can we solve for the RTH? Okay, where can we solve that one? Because there is no indicator that this is the part where we can solve for the VTH, this is the part where we can solve for the RTH, and so on and so forth. So wherever is your RL or your load resistors, load resistor, there's only one load resistor. Okay, so that is where you can find the value of RTH and VTH. Okay, so in other words, this is where you can find the RTH and the VTH. This open circuit right here. Okay, so I hope we're clear with that one, because some know the steps, like for example on how to solve the RTH and VTH, but they don't know where to solve the RTH and VTH. Okay, so wherever is your load resistor, that is where you can find the RTH and VTH. So in this case, we're going to solve for the RTH first. Okay, solving for RTH. Okay, so in here, in order for us to solve for the RTH, we have another step that we need to do. Okay, so after removing the load resistor, or after opening that one, so we have to remove all the voltage or current sources. Okay, that is the second step for us to be able to find the RTH. Okay, so as simple as that. So just remove the voltage sources. So we only have voltage sources, so just remove that one. So we actually have the same rule with, I don't know if it's a superposition theorem. Yes, it's superposition theorem. If it's a voltage source, okay, let's just see Vs. Okay, okay, just short it. Okay, and then if it's a current source, so Cs for current source, just break it, okay, or leave it open. So in here, as you guys can see, we have voltage source for the B1 and then B2. So just simply short this one. Okay, I'll remove this one and remove that one. And then just connect this one. Okay, so there you go. So from here, as you guys can see, we can now easily combine those two resistance. So, you know, RTH is actually like solving for the total resistance. Okay, so as you guys can see right here, it's like solving for the total resistance of this entire circuit, the R1 and R3. Okay, but before you can do that one, just take note that we didn't completely open this section right here. Okay, so if this one is completely open, well, of course we now have a series connection, but it's not. Okay, this one is now actually our node A, okay, and this one now is our node B, okay. And then if you guys are going to transform this one, okay, from here we have the node A and node B, and then this is the part wherein we have this line right here. Oops. And then we have this resistor for R1, and then we have this resistor for R3. Okay, and as you guys can see, they are not in series at all. Okay, they are actually in parallel with each other due to this node A and node B. Okay, so for us to be able to find the RTH, okay, so we have to apply the rules of parallel connection. Okay, so RTH is equal to R1 times R3 divided by R1 plus R3. Okay, and then from here, R1 is equal to 4 ohms, and then R3 is 1 ohm divided by no need for parentheses, so 4 for R1 and then 1 for R3. So in here you'll arrive with 4 divided by 4 times 1 is 4, and then 4 plus 1 is 5. Okay, wherein 4 over 5 is, I think, 0.8. Please verify if this is 0.8 ohms. Please check this one using your calculator, and then let me know if 0.8 is correct or no.
Correct, sir.
Correct. Okay. So that is if we have the the R load in here. Okay. But what if, okay, what if we have the, okay, tanggalin ko na muna to. What if we have the R load in here? Let's say this is now the part wherein it is open. So we have here now the node A and then node B. So since we don't have nodes in here anymore, so just simply add them. Okay, so that's already your RTH. So 4 plus 1 is your RTH. But since we have a node in here, so forming a parallel connection, so that is why we have 0.8 as your RTH. Okay, so the same scenario, if we have the, let's say, the R load in here on the bottom part, so we have the node B right here, and then the node A, or node A or node B. So this one will form is a series connection, okay, R1 plus R3. Okay, so that one really completely depends on the placement of your R load. Okay, so I hope we're clear with that one. Okay, so that depends now on your analysis on how you analyze the circuit. Okay, are they in series, are they in parallel, etc., etc. Okay, so this is already our answer for the RTH. Okay, as simple as that. So the only remaining one right now is the VTH. So let's solve for the VTH. So solving for VTH. Okay. Now, in solving for VTH, of course, we need to bring back the voltages that we just removed a while ago. Okay. So from here, let me copy this one again. Okay. And then, of course, we have to leave this one open. Okay, and this is now the part where we can find the VTH. Okay, now in solving for the VTH, that one is actually super simple. So as you guys can see, if you are going to analyze this one, okay, just the knowledge that you've learned on how to analyze a circuit. Okay, so as you guys may all know, we have a current that is flowing here. So we have this 28 voltage source. So from negative to positive. So the same with the right side. So we have the negative and then the positive. So we have a flow of current from this point to this point. Okay. Then of course, this voltage source will pass through this R1. Of course, it will have a voltage drop. Okay, so the same with this B2 right here. Upon passing through this right here, so you're going to have a voltage drop on R3. So whatever is a potential voltage of this left side area and then the right side area will be combined as one as your VTH. Okay, now how do we do that one? Okay, so in here we can actually apply. Okay, we can apply Kirchhoff's voltage law for us to be able to find the single current that is flowing in here. So applying 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 KVL to find the total current. Okay, the single total current. Okay. So in here, of course, one voltage source will dominate the entire circuit. Okay, there's no way that both of them will function at the same time. There is always one voltage source that will, dominate the entire circuit. So as you guys can see right here, if you guys are going to analyze this one, so we have a higher voltage source on the left side. So it's only a common sense, okay, that we're going to have this kind of flow up circuit. Okay, from left side to right side. Okay, so from here we can now have bakit yun ulit? We can now have a positive 28. Okay, so para hindi kayo malito, let me just put the signages. So negative here, positive here. Of course, it will give you a voltage drop in here. So positive and then negative, and in here it's positive and then negative, and then we have here positive and then negative. Going back here is 0. So if you guys are confused in some parts, so just ask me, okay? So from here, we will get positive 28 minus I, or the current, or the total current, times R1, okay? Minus I times R3, and then minus 7 volts. Going back to the original voltage source, it's now equal to 0. Okay, so we now have your equation for the KVL. So time check, it's 1 minute left. So since we don't have enough time anymore, so we'll just continue the rest on the part 2. So for now, goodbye and then see you guys later, okay?